PuzzleMe, leveraging peer assessment for in-class programming exercises. This work is done by April Wang, Chen, Chung, Christopher Brooks, and Steve Oney from University of Michigan. Peer assessment, as a form of collaborative learning, can engage students in active learning and improve their learning gains. Prior research has found that reviewing and testing each other's solutions can improve students' motivation, engagement, and learning gains, while reducing the effort required for instructors to provide scalable, personalized feedback. Peer assessment is typically conducted asynchronously rather than in a live classroom setting because current teaching platforms and programming environments provide little support to integrate peer assessment for in-class programming exercises. Designing real-time systems to support peer assessment for in-class programming exercises is challenging for several reasons. Prior research has made it easier for instructors to share and monitor code with multiple students in real time. However, designing real-time systems to enable both student-student interaction and student-instructor interactions in a live setting is still a challenge. Moreover, students may find it difficult to engage in peer assessment because of lack of expertise to identify problems in code and start a meaningful conversation. In a needs analysis study, we find that programming instructors often conduct in-class exercise to aid teaching. To conduct effective exercises, instructors get feedback from students on what they understand and then improvise exercises based on the feedback. It is often difficult for instructors to effectively break students up into groups with appropriate balances of expertise in the physical classroom situations. Further, because of the overall lack of expertise, peers can find it difficult to assess whether a given piece of code would fall on no edge cases, even if it generates the desired output for the test cases given by instructors. Driven by the findings, we formed 3 design goals for tools that scale support for in-class programming exercises. Improvising in-class exercises and synchronized code sharing. Instructors need a synchronized code sharing platform for improvising in-class exercises. Tools should support various teaching needs, including creating and sharing exercises, verifying students' solutions, monitoring students' progress and activities, and walking through answers. Scale student support. Students need to get timely and on-demand support during in-class programming exercises. Encourage live peer interaction. Tools should encourage students to interact with their peers in real time to engage them and motivate active learning. We designed a system named PuzzleMe to address all of these requirements. Next, let me walk you through the design of PuzzleMe. PuzzleMe is a peer-driven in-class programming exercises tool. Imagine this typical CS1 classroom with 1 instructor and more than 100 students. PuzzleMe allows the instructor David to create a puzzle sheet that contains 3 types of exercises: text response questions, multiple choice questions, and coding exercises. Students then join the puzzle sheet by a unique channel name and work on their solutions. PuzzleMe implements 2 assessment techniques tailored for the context of in-class programming exercises: peer testing and peer code review. Peer testing measures code robustness by allowing students to create and share lightweight and informal tests with peers. We break down the normal code editor into 3 parts: the setup code that specifies given conditions, the solution code that consists of student solutions, the assertion code that checks the expected behaviors that changed case by case. Students can create a new test case by editing the setup code and assertion code. In this example, student Alice creates a name list that contains middle names. A test case needs to be verified before sharing with others. When students click on the Verify button, PuzzleMe will verify the test case by assuring it passes a standard solution code provided by the instructor. Once the test case is verified, other students are able to see it and use it for testing their code. In this example, student Charlie passes the default test case provided by the instructor but fails the test case created by Alice. Peer testing ensures students to assess the correctness of their solutions. However, it doesn't provide feedback on how to solve the problem. In addition, some solutions may contain unnecessary steps or bad coding styles. PuzzleMe implements peer code review to improve code understanding by matching students intelligently to maximize meaningful conversations. We use two heuristics for matching learners. We pair students who have incorrect solutions with at least one student who has a correct solution. If a group has multiple students who have correct solutions, we pair a diverse set of implementations. In this example, once the instructor David enables the peer code review mode, Alice, Bob, and Charlie are matched together. Charlie has an incorrect solution, while Alice and Bob solve the problem in different ways. In total, we conducted 3 studies to evaluate the effectiveness of PuzzleMe for scaling support and its general applicability. To evaluate its effectiveness, we deployed PuzzleMe in an introductory programming class for 2 weeks. For the first week, we compared students' performance with and without the support of PuzzleMe in 4 lab sessions. For the second week, we collected and analyzed the PuzzleMe usage data for an online lecture. We then conducted an interview study with teaching staff from other programming classes to understand the broader applicability of PuzzleMe. Our evaluation studies demonstrate that the design of PuzzleMe allows instructors to improvise in-class programming exercises, while effectively leveraging peer feedback through live peer testing and live peer code review. In particular, PuzzleMe motivates students to write more test cases, identify gaps in their code, and explore alternative solutions. Next, we would like to highlight the design lessons from PuzzleMe. First design lesson we learned is that learner-sourced test case creation benefits multiple stakeholders. Although individual students' test case coverage might not be as thorough as those written by instructors, they save time and effort and enable improvised programming exercises. More importantly, the process of creating test cases helps learners verify their understanding of the problem and practice ability to predict the outcomes of given inputs by manually walking through their code. The test cases provide additional diagnostic materials for instructors, allowing them to reflect it on the misconceptions students formed and aiding in the design of future learning activities. The second design lesson we highlighted is the social and cultural value of building collaborative learning platforms. We observed that students use topics related to their interests when creating test cases. For example, in the name sorting exercise, students created test cases using names that are popular nationally, regionally, and culturally. This shed light on the unique social and cultural aspects of students' background. We believe that the opportunity to create test cases related to their interests adds additional motivation for students to engage in the test creation process. Lastly, we would like to highlight the challenges of connecting students in live classrooms. As we found when designing PuzzleMe, students might feel shy or hesitant to talk to each other, especially in situations that might expose their lack of understanding of the material to their peers, such as asking for help. We proposed various design decisions to create an encouraging collaborative space, such as providing real-time feedback on test cases so that students are comfortable sharing them with others, keeping students anonymous when sharing code and reviews, and allowing instructors to monitor and intervene in group conversations. However, our evaluation suggests that prompting conversations between students is still challenging. Compared to live code review, students might feel more comfortable with non-conversational interaction with peers, such as sharing and using test cases created by others. Future research could look into the reasons that students fail to connect with their peers and address the challenge from both social and technical perspective. In summary, this paper presents PuzzleMe, an in-class programming exercise tool for providing high-quality peer feedback at scale. For more details, please read our paper.